Start recording.
This is the Superconductors bringing to you our progress report on our automatic box line maintenance. This is Omar Sukar, electrical engineering major, and my peers are.
Hey, I'm Nolan Robinson, an electrical engineering major.
I'm Patrick Kay. I'm a computer engineer major. Oh, oops. I think that's gone.
Summary. The goal of our project is to design and build a device to automatically apply lubricant to the cam followers on the box line. While this task is reoccurring frequently, it becomes time-consuming as much as 6 hours a month on one task. By using the design of our system, we can eliminate the need of a mechanic to perform the task, which will save labor. Most importantly, avoid a possible injury, since this task is performed while the box line is in operation. Our mechanic will automatically apply an appropriate amount of lube to each cam follower and will catch any excess lube to go through a filter and remove any debris. In addition, it can count the number of times it sprays, which will provide us with the cart number it stops at in case of an emergency stop, and that will avoid the need to start over to figure out where the process last ended. Lastly, it will be app controlled for easy use and to eliminate the need of going to the machine unless it needs to be refilled with lubricant every few months. This device will rest underneath the track for easy access to the cam follower of the boxline train. The device will include a funnel to collect excess spray and bring it back into the system tank after filtering debris. Sensors will detect how close the next cam follower is, and depending on the distance of the device, it will spray the cam follower. The technician will input the number of cars on the specific box line, and then whenever the timer goes off, it will start spraying in the cam followers while counting off the cars. Once the counter reaches 0, the system will stop spraying. All right, next slide. Here's a picture of the box line and the cam follower. As you see, the cam follower is highlighted on the right side in the red box. That is basically the track. The device will rest underneath the track and will spray the cam followers. It will be probably placed in a place where the track is a little bit higher than this. This is the beginning of the track, so it'll be probably at the end of the track where there's a higher elevation. All right, we can go to the next slide. We have some design changes that we implemented, some power systems, some devices we removed, some things we added. So the first change we did is power systems. The previous chosen power system, it was a step-down transformer. It was rated at 12 volts and 10 amps, but that might put some restraints on our power supply, and that is because our devices add up to 10 amps exactly, and we don't want to put any restraints and heavy load on the device, and we don't want to cause damage to it or overheating problems. So we decided to go with a higher ampage one, supply more power, more wattage for our devices for safety room. We also removed the QR reader. It added a little to the design's functionality and required extra device setup time than was necessary. QR readers are also not that accurate, and in low light it will be kind of hard to detect, so we decided just to remove it. In response to testing difficulties, our prototype design will use a water pump in the place of an oil pump, and that because we're going to test it at our houses, so therefore it will be really messy to try and use an oil pump to do it. Unfortunately, we couldn't do it at UPS, but in that case, we're going to be making our water pump work as an oil pump and provide the same pressure as the oil pump that we were going to use. For the actuator system, we have recently received a 12-inch one, but unfortunately it turned out to be way too long because the housing of it is 13 inches by itself, plus the 12 inches for the expansion, so it was a very long distance of travel, and we didn't really need that, so we're switching to the 6-inch one that can be controlled with an Arduino as well, and Nolan will take it from here on functional decomp.
All right, this is our functional decomposition for the automatic lube spraying. As you can see, the inputs to the checklist, which I will go in more detail over, are the track position, oil level, and user input. I can go to the next slide. So the oil level trace. The oil will be resting inside of a tank There will be a floating sensor inside the tank that will notify the user how much oil is left inside the tank. The sensor will float down with the level of the oil along a rod that it's connected to. If the user believes the oil level is enough to run through a test, they can begin the process. The system will then go through the checklist, ensuring that everything is satisfied, and the pump control will then activate the linear actuator to put the drip tray in place, and will pump the oil with the oil spray. Next, please. The track position trays, so each box line is made into a big circle with box cars lined up along the track. The track position is used to show how far along the box line the process of lubing the cars is. The user will need to enter the number of box cars in the app to give the system a number to count down from. With this information, the photo eye sensor will detect a box car as it's moving and count down from the inputted number to 0, indicating all cars have been lubed. If the photo eye sensor is working properly and passes the checklist, the system will begin its process. Next, please. User input trace. The user will be using an app that Patrick will show later in the slides. The app will be able to show how much oil is in the tank and how many cars are left to oil as the system is running. The app will connect via Bluetooth to the Arduino. If the user believes all components are satisfied, the user may activate the system. The system will run a quick diagnostics to satisfy its checklist. This will turn on the pump control and the photo eye to detect the cars and begin the process. All right, next.
Parts delivery status. As we've said, there have been several delays in the delivery of our parts, so I'm briefly going to cover what has arrived and what is being delivered. For the power supply, it actually arrived today. Omar talked about why we need to order a new linear actuator, and it is coming from Canada, so there could be considerable delays. The Bluetooth module and the photo eye sensors are arriving very soon as well, but they have been held up the most. So if they continue to be delayed, then we may need to consider ordering new ones with shorter delivery times. Project status and focus. Since many of our parts have been delayed, our focus has mainly been on programming. So our aim has been to have software ready for when the parts arrive. This way, we can begin testing them right away and integrate the parts after that. We have also been working on programming our app and looking at various software for that. What we have settled on using is the MIT App Inventor, which is an online GUI editor and programmer for Android apps. Without the Bluetooth module, though, there's only so much we can do. You can see a basic outline of the app's design here on the right. This isn't what the final version is going to look like, but it should be something similar. Other modules in progress. These modules are the ones based on the parts that have arrived. For the most part, these parts have allowed us to test that their software is working. This is what we've been doing for the float sensor and the linear actuator. We verified that these parts are functional using the software. The diaphragm pump is the part that has most recently arrived, so we are still in the process of testing it and the software for it. Once more of the parts arrive, we will then verify more of the parts using the tools in the university lab. The project has been delayed due to the delay of our parts delivery, but we should be able to make up for it because most of the software is done. The actual construction of the device should not take too much time. The majority of our remaining time will be making sure that the timing for all the parts and their activation is correct.